Good morning, children. This is our chapter number 4, motion in plane, and we are doing the topic circular motion. Under that topic, today we are going to cover the topic that is relation between the linear velocity and the angular velocity. So, suppose children, a particle is moving on a circular path and the radius of the circular path is r with the center of the circle as O. Suppose children, initially the particle is at point P and after time delta t, it reaches point Q, covering a distance of del S, on the circumference of the circle. And during this time del t, and during this distance covered, that is del S, the angle that is traced at the center be del theta. Now children, we know that angle equals to arc into radius, arc upon radius, right? So angle is del S, angle is del theta, arc is del S, and radius is r. And if we make del S subject of formula, then del S will be equal to r del theta. Now children, what we are going to do is, this del S distance is covered in time del t. So we are going to divide this equation by del t. Now here children, del t, if we assume del t to be very small, so del t tends to 0. So our del will change to d. So instead of del S by del t, we will have ds by dt. That will be equal to r del theta by del t, and instead of del theta by del t, we will have d theta by dt, because here children, the time t tends to 0, that is very small. So here children, ds by dt will give you the instantaneous linear velocity, because this is the distance covered. And the angular distance is theta. So d theta by dt is the instantaneous angular velocity, right? So we know that the angular velocity is represented by omega and instantaneous velocity is represented by v. So our equation will become v equals to r omega. V equals to r omega. So this is your equation, that is v equals to r omega. Now children, we know velocity, linear velocity, this is a vector quantity. Angular velocity is a vector quantity. R is the position vector of the particle with respect to origin. So if the particle is at point P, then with respect to origin O, this OP is equal to the position vector, right, of the particle from the center. So that is r, that is again a vector. So if you want to represent this v equals to r omega in terms of vector, then that will be represented as vector v equals to vector omega cross r. Now children, if we talk about the direction of v, so we know that it is omega cross r. So the direction of v is perpendicular to the plane containing omega and r. Okay, so here children, we can apply right hand thumb rule. That is, you will stretch your fingers in the direction, right hand fingers in the direction of omega, that is the angular velocity, and you will rotate, or you will curl your fingers, you will curl your right hand fingers in the direction of position vector. So once you do, you will see that your thumb is pointing, your right hand thumb is pointing in perpendicularly outward direction, right? So it is upwards. So children, here the direction of velocity v is tangentially upwards. So at each and every point, the direction of velocity v will be tangentially upwards. So children, this is the relation between the linear velocity v and the angular velocity omega. And the direction of v is given by right hand thumb rule. That is it is perpendicular to the plane containing omega and r. Now children, let's derive the relation between the angular acceleration and the linear acceleration. We just now derived the relation between angular velocity and linear velocity, right children? So we know this relation, that is V equals to omega cross R, right? Where V is the linear velocity, omega is the angular velocity, and r is the position vector of the particle from the center, right? And its direction will be from O to the particle, right children? So the magnitude of the position vector r is equal to the radius of the circle. Now children, here we are assuming that a particle at any particular time of instant is at this point, let this point be called P, and the particle is moving with linear velocity V. The particle is moving with linear velocity V. And as the particle is moving on a circular path, it will have angular velocity also, right? And its angular velocity is omega. And at that point P, let the position vector of the particle be vector R. So we know that vector V equals to vector omega cross vector R will be the relation between the linear velocity and the angular velocity. And we saw that the direction of the V is along the tangent. It is tangentially upwards, right children? So V is a tangential vector, and omega, that is here the angular velocity, it is along an axis. So omega is an axial vector, and the position vector, that is along the radius, so it is known as a radial vector. Now children, all these three vectors, that is V, omega and r, they are mutually perpendicular to each other. V is perpendicular to omega, omega is perpendicular to r. Right. Now what do you have to find over here? Acceleration. Now children, we know acceleration is rate of change of linear velocity, right? Acceleration is rate of change of linear velocity. So we can write A equals to dv by dt. Now we can replace, instead of V, we will put this value. So this value, on substituting this value, we will get, instead of V, omega cross R. Okay, so first we will do the differentiation of omega, r will remain in cross as it is, then we will keep omega as it is, cross the differentiation of the position vector r, the radial vector r. Okay children, now here we need to identify the terms. This is d omega by dt. Omega is the angular velocity. So rate of change of angular velocity will be angular acceleration. Yes, rate of change of angular velocity will be angular acceleration, which is denoted by children alpha, which is denoted by alpha. So you will have alpha cross r plus omega cross dr by dt. Here r is the position vector, right? So here r is the radius. If we talk about magnitude, it is the radius of the circle, right? So the change in dr by dt, that is a linear term, and that is the linear velocity, because your r is what? It is distance, right? It is the displacement. So rate of change of displacement will be with a velocity. So here you will have v. So this is your equation, that is alpha, yeah, alpha cross r plus omega cross v, right children? So we got this equation. Now children, here we have to be careful that alpha cross r, that is the component of acceleration. See, these both, they add up to give the linear acceleration, right? They added to give the linear acceleration. So we have to identify both these components. Now, alpha cross r, children. Let's talk about first alpha cross r. Alpha is the angular acceleration. Now we know that the angular acceleration is rate of change of angular velocity. Now children, angular velocity is along the axis of the rotation. Along this line, the angular velocity is going to take place, right? So the direction of the angular acceleration and the angular velocity will be same if the speed of the particle is increasing. So children, if the speed of the particle is increasing, then the direction of angular acceleration, that is alpha, will be along omega. वो omega के along होगा. So हम इस diagram में will represent the direction of alpha, that will be this. Right. But children, if the speed of the particle is decreasing, then the direction of alpha will be opposite to the direction of omega, that is angular velocity, right? It will be opposite, but it is always going to be along the axis of rotation. वो जो axis है उसी के along उसका direction होगा, right, either upward or downward. Okay, so alpha direction we came to know, right? So suppose the speed of the particle is increasing. So if the speed of the particle is increasing, then the alpha and omega, they will be along the same direction. That is, they will be upwards along the axis of rotation. Right, children? So this is your alpha. Okay, next. So this alpha cross R, if you see alpha is in, if you think about y-axis, right? Alpha is in y-axis and this is your r. So if we see a component, if we see an axis which is perpendicular to y and r, it will be in the direction of tangent. So your this velocity, that is alpha cross r, will be, its direction will be along the tangent. Right, so this is the acceleration component which is known as the tangential acceleration. Let's talk about the next second one, that is angular velocity omega into linear velocity v. So children, this is the component which is going to keep the object attracted towards the center and force it to move on the circular path. So this is a component which provides the centripetal force, centripetal acceleration, right? This is along the tangent and this is along the center. That is, this is centripetal acceleration. So this is vector, that is acceleration, centripetal acceleration. So your AT is alpha cross r, that is tangential acceleration, and AC, which is cross product of both the velocities, that is angular velocity omega into linear velocity v, which is known as the centripetal acceleration. So both tangential acceleration and centripetal acceleration, they are the two components of the linear acceleration. This is the relation between the tangential acceleration and the centripetal acceleration, or rather you can say that the relation between the angular and the linear acceleration is given by this, right? Okay. So children, now let's study in detail about the tangential acceleration and the centripetal acceleration. So children, just now we derived the relation between the linear acceleration RA and the angular acceleration, that is alpha. So this equation gives us the relation between them. Now we know that alpha cross R, right, that is the angular acceleration alpha cross product with the position vector r, gives us the tangential acceleration. gives us the tangential acceleration, right? And the cross product of angular velocity omega and linear velocity v. So the cross product of both the velocities, that is angular cross linear velocity, will give us the centripetal acceleration, that is AC. And we know this, that is, this is a relation between the linear velocity v and the angular velocity omega, right? This we have derived. Now children, here we know that the direction of the tangential acceleration is along the tangent. It is along the velocity, right? When a particle is moving on a circular path, at any point if you want to find the direction of the particle, right, then that can be found out by drawing a tangent, right? So the tangent gives the direction of the velocity, right children? So same will be the direction of the tangential acceleration. And talking about the centripetal acceleration, so centripetal acceleration will be directed towards the center, will be directed from the position of the particle towards the center of the circle. This was about the direction. Now let's see about the tangential acceleration. So children, tangential acceleration, as we know, it is denoted by the symbol vector AT, which is equals to alpha cross r. Now children, its direction will be parallel to velocity. Its direction is along the velocity component, right? Its direction is along the tangent. So children, here, moreover here children, the direction, the angle between omega and alpha, the direction between omega and alpha, they are going to be parallel. They are going to be along the axis of rotation, right children? So the angle between the velocity and tangential, they will be parallel. They are along the tangent. Both of them are along the tangent. So children, here the angle between them will be 90 degree. So sine 90 is 1, and so the magnitude of tangential acceleration will be alpha r. Okay, and its direction is along v, along tangent, and this AT is responsible for the change in speed of the particle. That is, AT gives us the magnitude of rate of change of speed of the particle. Okay, next is centripetal acceleration. So centripetal acceleration, we know it is given by AC equals to omega, vector omega cross vector C, vector V, right? Now centripetal acceleration can be provided by different forces in different conditions. For example, here if we are talking about the nucleus, so in the nucleus we have protons and electrons are revolving around the nucleus. So as the electrons are moving on a circular orbit, so that the centripetal force required by the electron to move on a circular path along the circular path is provided by, that centripetal force is provided by the electrostatic force. Similarly, if we throw a charge at 90 degree in the magnetic field, then it will start performing circular motion. So here who is providing the centripetal force? Here the magnetic force is responsible for providing the centripetal force. Similarly, when the car is moving on a circular turn, at that time the necessary centripetal force is provided by the frictional force. Right, and suppose you tie a stone with a thread and then you revolve the stone, you rotate it, then the stone moves on a circular path. There the centripetal force is provided by the tension force which is present in the string, so that provides this necessary centripetal force. And talking about the motion of earth around the sun, So it is almost a circular motion, right? So here who is providing? Here the gravitational force of the sun is responsible for providing the centripetal force to the earth. So your centripetal force is given by AC equals to omega cross V. And if we talk about its magnitude, right, its magnitude will be maximum when the sine of the angle between them is 90 degree. Moreover, children, here R, if you see, is in I. The R, it is in I direction. I is what? Positive X, right, beta? Omega is in J vector, right? That is positive Y. Then if you see, then if you do the cross product of them, that is AC equals to omega cross. Instead of V, can I put omega cross R? Right, children? So it is what? It is omega कौन सा है? J into J cross I. Now J cross I we know it is minus K. So minus J cross minus K is minus I cap. So it is opposite to the direction of R, and its magnitude is given by omega V. Its magnitude is given by omega V. So centripetal acceleration, we are having these formulas, that is omega V. If in this formula we substitute the value of omega, that is omega equals to V upon R, then this equation will come, children. And if we substitute the value of V as R omega, then it will be omega square R. So these are the forces, magnitude of centripetal force. So centripetal force, children, it is always perpendicular to the velocity, and it provides and the work done by this centripetal force is always zero. Next, children, if a particle is moving on a curved path, then there are two components of acceleration. One tangential component, that is along tangent, that is along velocity, and another is perpendicular component, that is perpendicular to V, and that is along the position of the particle towards the center of the circle, that is centripetal acceleration, right? So net linear acceleration is sum of the tangential acceleration and the centripetal acceleration. And if we talk about magnitude, then it will be under root of AT square plus AC square.